Hello, Mr. McKilla. My molecule that I've created is called Zenti-fluorocarbox, which is used for non-sticking pans and where the pan can cook food in it without leaving any of the food stains on it. And so because of that, I would need a non-polar molecule. My molecule is composed of 6 carbons, 11 fluorine, 1 xeno, 1 hydrogen atom, which has a molar mass of 413.37 grams per mole. Alright, so let's look at the shape of the molecule first. So I'm going to describe the 2D molecule first with all the different types of bond angles. So if you look at the bottom right, the 2 dotted means a lone pair of electrons. Straight line just means bond. 90-degree angle has that 90-degree shape. The 4 single line brackets is the tetrahedral shape, which has a bond angle of 109.5 degrees each. And the double line that only has 3 connected double lines is the trigonal planar shape, which has a 120-degree bond angle each. So if we look at the central atom, the xeno, which is a noble gas, is currently in a trigonal bipyramidal, which has bond angles of 120 degrees and 90 degrees. So the 120-degree ones are bonded between the lone pairs of electrons, while the 90-degree ones are bonded to the left and the right carbon atoms. So if we look to the right of the molecule, we have 3 carbon atoms, each attached to 2 fluorine, making this extremely nonpolar shaped and having a tetrahedral bond, so of 109.5 degrees each. And if we look all the way to the right, there is a hydrogen atom bonded to it. And to the left of it is exactly the same, but instead of a hydrogen atom, is all just carbon and fluorine atoms. And instead of all being tetrahedral shaped, it actually has a trigonal planar.
So this would be the atom actually in shape with all the wedges and dotted lines, wedges coming out of the page, dotted going inside the page. The blue symbolizes fluorine, red is carbon, yellow is xeno, which is in an expanded octet form. The purple at the top right here is the hydrogen, and the green are the lone pairs of electron. So if you look at the shape, it's very similar to this one. It's based directly off that. As we could see, this is currently in a trigonal bipyramidal shape, the 90 degrees, the wedges being the 120 degrees. And you can see overall, to the right, it's just all tetrahedral shapes, 109.5 degree bond angles, all the wedges and dotted line connected to the fluorine. And to the left of it, there's 2 trigonal planar with 120 degrees each, flat on the page. And overall, this shape is a very hydrophobic structure. It's very non-polar, which gives it the high melting point property. And as you can see, this my atom's based heavily on PTFE, polytetrafluorine ethylene. As you can see, the shape, you see this pattern being repeated here, CCFFF, and in this shape over here.
According to PTFE machinery, polytetrafluorine ethylene, which my molecule is influenced by, has a melting point of 327 degrees Celsius and a boiling point of around 400 degrees Celsius. My molecule possesses a much longer chain than the common PTFE, and while possessing the same C carbon to fluorine bond, so I would assume that it will have a higher melting point and boiling point. So I would estimate my melting point is around 360 degrees Celsius, higher than 327 degrees Celsius melting point of the other one, and a boiling point of 440 degrees Celsius, higher than the before 400 degrees Celsius one. One reaction my molecule would undergo would be halogenation reaction or addition reaction, since it is an unsaturated molecule. For example, fluorine gas 2-fluorine, if it would be added to the double bonded carbon atom, removing the double bond and creating a complete tetrahedron. But it would be hard to bond with this molecule because of its long and nonpolar properties. The xeno atom is The xeno atom in the middle is also an expanded octet as it has more than 8 atoms in its valence shell. And so my molecule, the central atom, has 10 valence electrons surrounding it, as from the 2 carbons surrounding it and the full octet of electrons that the xeno possesses itself as a Nobel gas, since it can use its empty 5d orbital, enabling it to hold more than 8 electrons and form stable bonds with fluorine atoms.